So in this capsule, we'll look at representing organic molecules. We'll take a step higher than the loose dot structures. So there are three levels of drawing structures. As we go from loose dot structures to condensed structures and skeletal structures, we'll be representing the same compound but in simpler forms, that saves us time. So we have already got three examples. One example there, loose dot structure of methane, CH4, you see CH4, which can be rewritten like this. With electrons, and here we are using a line to represent a bond, a carbon-hydrogen single bond, therefore such things. So this is the condensed structure of CH4. We just take the carbon and put how many hydrogens are there on the carbon, that way, so CH4. In this case it happens to be the molecular formula too, but if we progressively go to higher structure, structures with more carbons, then we will see the usefulness of the condensed structures and skeletal structures. So let's move away from loose dot structures from now onwards. So let's draw a compound C2. The molecular formula is C2H6. That's the molecular formula. So we can draw, instead of showing those electrons, we can just show the bonds. So this is C2H6, a loose dot structure, but collapsed into without showing the electrons or showing the bonds. So C2H6. Now, it becomes time consuming, especially if you have to draw like C10, a compound having 10 carbons in this fashion. It just becomes time consuming, takes too much space, all those things. So people have developed drawing other types of structures. So let's take a look at what a condensed structure means. So in the condensed structure, what we do is take this carbon, let's call this carbon 1 and carbon 2. So let's take carbon 1. Carbon 1 is connected to 3 hydrogens, so put the 3 hydrogens that way. So we collapse this or condense that into a simpler CH3. Likewise, it's C1, right? Just denoting carbon 1, and then carbon 2 as well has 3 carbons. So if we remove the 1 and 2, that's just for our understanding, we don't need to do that. So this will be like a condensed structure, CH3. 3 hydrogens connected to that carbon is connected to another carbon, and that carbon is connected to 3 hydrogens. Okay? Now, so we took a look at what a condensed structure looks like. By the way, this molecule, 2 carbon, it's an alkane, as you see. It's a hydrocarbon. It has only carbons and hydrogens in this compound, so it is a hydrocarbon. Specifically, it's an alkane because it has only carbon-carbon single bonds. And the specific name for this particular compound is ethane. So we're learning different things while talking about stuff. Hydrocarbon, Uber class, specific class is alkane, specific name for this particular compound is ethane. So notice ANE alkane, the name also ends with ANE ethane. Now, let's go 1 carbon higher, and then we can talk about skeletal structures. Okay? 1 carbon higher, let us condensed structures. 1 carbon higher will be 3 carbons and 8 hydrogens. We'll talk about many things. 3 carbons, 8 hydrogens. So the long form showing every bond explicitly is the structure will be like this. Explicitly showing every carbon, every hydrogen. So now let's simplify this further, go to the condensed structure. So this one will be like a CH3. this is CH2, Victoria bond CH2, and then another carbon CH3. So this is a condensed structure. These two basically are the same thing, there's no difference. Denote the same compound. By the way, this compound is propane. Again, notice ANE denotes, ending with ANE denotes that the compound is an alkane. That means it has only carbon-carbon single bonds, and the lower class is hydrocarbons. So propane also belongs to hydrocarbon class. Specific class is alkanes, has only carbon-carbon single bonds. The name for this particular compound is propane. Okay. Now, let's come down to even more simplified structures, skeletal structures. In this we show only the skeleton, we omit the hydrogens, okay? And it is shown like this. So, now skeletal structures of this compound, I'll just draw that here again, CH3, CH2, CH3. So the skeletal structure of this particular compound, propane, is simply shown like this. Okay, this is a most simplified way of denoting the structure of a given compound. So what does this mean? So here you focus on these three things. Okay. Each of them is a carbon. So there's a carbon there, there's a carbon there, and there's a carbon there. Okay. Now, we know carbons form 4 bonds, right? Every carbon forms 4 bonds. Okay. So, notice this, I'll number them. Carbon 1, carbon 2, carbon 3. Okay. You can also number the other way. It doesn't matter because either way gives you something. Anyway. So, carbon 1, you see, carbon 1, which is this, has 1 bond. That means this carbon has 3 hydrogens. We omit those things. So it's like this. Okay. So let's put that here. So carbon 1 is simply shown like that. It's understood that this carbon has 3 hydrogens because this carbon has only 1 bond. Carbon forms 4 bonds. Every carbon forms 4 bonds. This carbon here, you see 1 bond, so the 3 bonds are assumed to be with hydrogens. Presumed to be with hydrogens. Okay. Now let's go to carbon 2. Carbon 2 is forming 2 bonds. 1 bond there, 1 bond there. So carbon 2 will have only 2 hydrogens. So see this, 2 hydrogens, omitted them. And carbon 3 forms 1 bond with carbon 2 and the other 3 are hydrogens. So progressively we are simplifying how we denote structures. And this is what we'll be using going forward. This is what we'll be using. So we need to get familiar with this. Okay. Now let's go 1 carbon higher. C4H10. C4H10. Okay. So we'll draw all 3 ways of representing for practice. So let's number them C1, C2, C3, C4. This is the most explicit structure. This can be collapsed to CH3 connected to CH2 connected to another CH2 connected to the CH3. Okay. So if you want to count whether there are 4 carbons, of course there are 4 carbons. That's more clear. Let's count hydrogens. 3 hydrogens plus 2, 5, plus 2, 7, plus 3, 10. So C4H10. Now, how do we represent this? using skeletal structure. So there are 4 carbons, right? So our line will start, easier to start that way. So carbon 1, carbon 2, carbon 3, carbon 4. You can see carbon 1 and carbon 4 are forming only one bond, carbon 4 with carbon 3, carbon 1 with carbon 2. So carbon 1 and carbon 4 will have 3 hydrogens. We are not showing them, but sometimes if we need to show them, we show them like this, 3 hydrogens there. But more often than not, we just not show them. Sometimes we show them if needed, for some reason. Otherwise, this is butane. The name of this compound is butane. 4 carbon alkane. Butane is an alkane. It's a hydrocarbon. Again, carbon hydrogens only, so it's a hydrocarbon. It's an alkane because it has only carbon-carbon single bonds. The specific name for this compound, this particular compound, is butane. This way we wrote that, 4 carbons. Okay? So this is how we represent organic structures. Now, we'll do one small problem. We'll start with a skeletal structure and determine its molecular formula. Okay? So let's do this. I will do, just to complicate this stuff a bit, I'll do it that way. So now let's number the carbons first. So there's a carbon there, 2, 3, 4, 5, 6. There's 6 carbons, so C6. Now let's take a look at each carbon. Carbon 1 has only one bond with carbon 2. So carbon 1 will have 3 hydrogens. Carbon 1 will have 3 hydrogens. Carbon 2, this carbon 2 has, you see it has 3 bonds. One with carbon 1, one with carbon 3, and one with carbon 6. So carbon 2 has only 1 hydrogen. Carbon 3 has 2 bonds. So carbon 3 will have 2 hydrogens. Carbon 4, similar board. Carbon 5, 3 hydrogens. Carbon 6, 3 hydrogens. So let's add them up. 3, 4, 6, 8, 11, 14. So this is the molecular formula of this condensed structure. Okay. We'll come to naming later. I'll just write the name here, but we'll come to naming in a different video. 2-methyl-pentane is the name of this compound, systematic name for this compound. How we come to that will be a topic of another capsule. Okay? We'll stop here.